So last time we started section P.6 Rational Expressions. We didn't get very far in, but we had talked about domain. Remember that? And the domain are the x values that are allowed or able to be used into a rational expression. And not just true for rational expressions, but that's where we were looking at last time. And in particular, what we did is we looked at places where that made the denominator 0 and said, well, that's not allowed. And so we sort of kind of counterintuitively stated it that way. On this one, on number 3, we even talked about that we could change the directions, and the directions might say something like simplify. And if we did, we would notice that the x plus 2 on top and the x plus 2 on bottom match, and we might do something what you probably would call cancel out or reduce. And that's actually where we're headed next. We're going to simplify these next two expressions. And in order to simplify, to reduce, we actually have to be able to factor. That's the way that we are able to reduce. So taking a look then, sorry, my tools are set up wrong. Taking a look at the top of this, we are able to, hey guys, we're already started. Just come in quietly, please. We're able to take a look at what they can actually be factored out. So the entire numerator says negative 2x minus 4. What is common to both pieces of that? What can be factored out? Negative 2, exactly. So if I pull out a negative 2, what am I left with? Close, plus, because we pulled out the negative. So x plus 2, yes. Now, the denominator is a polynomial. Well, the numerator is too. But it's a trinomial in particular. And we talked last time when we were looking at section P5 a lot about how to factor trinomials. And in particular, we did a method called the AC method. And the AC method, it works all the time, but it's particularly useful when the factor's complicated, right? When the factoring is complicated. So in a few situations last time and then also this time, when the factoring isn't complicated, I'm not going to go through the AC method. I'm going to assume that if you need the AC method, you'll use it. And otherwise, we may use trial and error because the trial and error is not too difficult. So on this one, that's our situation. The trial and error for this is simply not too difficult. And in part, that's because the coefficient on the x squared term is a 1. So if I have x squared at the beginning, there is only one way that I can factor x squared and get what I need. It would be x and x. So those two have no choices. The 10 at the end only has two choices. I can only get a 10 by multiplying 10 and 1 or 5 and 2. So I only have a couple of options. If I choose the wrong one, I'm not really up a creek very far. I just change what I've chosen and I move on. So on this one, I need two numbers that multiply to give me negative 10. And then look at the middle term. They have to add to give me negative 3. So what would those numbers be? Negative 5 and positive 2. Okay? Now, here's another piece of advice for you when you're looking at factoring these. The only way that this problem gets any simpler, which is the directions, simplify, is if there's something that matches what's on top with what's on bottom. X plus 2. So I'm expecting that there's going to be an x plus 2 on bottom. Otherwise, I can't really do what the directions are saying. Nothing to simplify, right? So there is this expectation as I do this that I'm going to get that x plus 2. They do, in fact, cancel or simplify or reduce, leaving me with a negative 2 on top and an x minus 5 on bottom. Any questions on that one? All right, example number 4 looks like some special factoring that we did in section P.5. It actually was 2 class periods ago, which is a week at this point. What does the numerator look like to you? Difference of cubes, right? There's cubes in there. And what about the denominator? Difference of squares. So I want you to take just a minute. I want you to attempt, as your best attempt, to remember the details and so forth, and factor the numerator and the denominator. And then we'll make sure that we all have the same thing. Okay? So factor the numerator with difference of cubes. Factor the denominator with difference of squares. All right, what'd you guys get on the top for the difference of cubes? Good. That sounds great. And how about on bottom? Fabulous. And then what reduces? The a minus b's. You don't need to worry about trying to simplify that trinomial. I mentioned it before, but I will mention it again. It is always going to be prime once you get to that point, okay? So our final answer then is a squared plus ab plus b squared over a plus b. And there aren't any more factors that can be reduced. Look good? Okay. Change of directions then. So we're kind of looking at all of the things we can do with rational expressions. We looked at domain, we've looked at simplifying. The next thing we're going to look at is multiplying or dividing. Okay, so we're going to multiply or divide for the next couple of examples. This one's pretty straightforward because there's no addition or subtraction. It's just all monomials. There's two ways that the problem could be done. One way is you could multiply everything on top, multiply everything on bottom, and then reduce the things they have from top to bottom. And that's totally fine. You can do that. The second thing you could do is you could do the reducing first, clean it all up, and then multiply second. And it's also fine. I kind of like to reduce first because the numbers stay smaller. And it's easier to do the reducing for me if the numbers are smaller. So there's two things to look at, you could say three even, on reducing. These are each fractions, right? So we've got a fraction here, we've got a fraction here. And obviously we know from a specific single fraction in the last two examples we did, if there are factors on top and on bottom in common, they can reduce. So we're going to look at the first one. We've got 14w over 51y. Are there any reducing, any numbers in common, any variables in common that can be simplified here? There's not on this one. How about the 3w and the 7y? Also there's not. Okay, so that's one thing to check, top to bottom on a single fraction. The next thing to check is diagonals. So if I cross a diagonal, top left to bottom right, are there any reducing amounts that we can reduce by there? And there are. 14 and 7 both divide by what? 7, which it's okay, which gives me a 2. That's where your 2 is coming from. And on the 7, it gives me a 1. And then the w and the y there, they don't simplify. The other diagonal, bottom left to top right, 51 and 3. Okay, so those do reduce. And in case you've never seen it before, I want to give you a couple of sort of tidbits of how you could know. If you weren't sure, of course, you can grab your calculator, see if 51 actually divides by 3. It will. The other thing you can know is that if you take 5 plus 1, what do you get? 6. Does 6 divide by 3? Yes, so 51 will too. That's a trick with division by 3s, and it's a pretty cool trick, especially if you did have a long value that you were trying to divide and maybe you didn't have a calculator, just there to check it real quick for yourself. You add the numbers together. If they divide by 3, the whole thing divides by 3. What's even cooler is it actually works for 9s as well. If you add all the numbers together and they divide by 9, the original number divides by 9 too. So this one works, and if you do grab your calculator or do your division in your head or on your paper really quick, 3 obviously divides by 3 one time, right? If I divide 51 by 3, what do I get? 17. Good job. And again, on that diagonal, I've got a w and I've got a y, and they don't simplify either. So once I've done all the simplifying I can do, I can multiply across the top. 2 times 1 is 2. W times w is w squared. On bottom, 17 times 1, 17. And then y times y, y squared. Is that yellow readable enough for you guys? Do I need to not use it? It's okay? It's okay. All right. If I were to use it in the other classroom, it doesn't okay, actually, so just checking. Fun times. All right. You ready for one that's a little bit more fun? I know, that was a really mean thing to say, wasn't it? Fun is all relative. It's a description, right? Fun is relative. All right, so the first thing you probably should notice is that this is not multiplication. It's division. Okay, so what you'll remember about division of fractions is the way that we divide fractions is we take the second fraction and we flip it. It's called the reciprocal when we do that. And it becomes multiplication. So the very first thing I'm going to do is simply do a rewrite step. All right? Everything in the first fraction is going to stay the same. My second fraction is going to invert or flip. Okay, everybody good so far? Rewriting, lots of fun rewriting. Okay, so taking a look at this then, the only way things simplify with rational expressions is if they simplify from the factors of them. Okay, we've got to look at the factors. And right now, this is not in factored form. Not only that, but these are not nice, neat, clean, pretty, simple problems to factor like 4 and 5 were, are they? I've got coefficients on x squared that are not 1. I've got numbers like 20 and 25, especially 20, that have multiple ways of getting them, right? Multiple options, not just 1 or 2. So it makes the problem more challenging. If you want to use guess and check, that's fine. You can still do that. But just as a reminder, refresher, and because you're still working on P.5 potentially for your homework that's due at midnight, which means you might still be working on the AC method, right? We're going to do the AC method. We're going to do it 4 times. That's exactly how many times we're going to do it. It's so exciting. Okay, first problem, top numerator, okay? 3a squared plus a minus 4. A times c. What is a times c for that numerator? Negative 12. And b is 1. I need 2 numbers that multiply to negative 12 and add to 1.
Negative 3, positive 4.
Okay, negative 3, and then it'll be a, and positive 4a. And then I have my subtraction of 4 at the end. So I took the middle term a and I separated into negative 3a and positive 4a. Now, the second fraction, or the first fraction, second piece, the denominator, it's not in a very friendly form because the a squared's at the end instead of the beginning. That makes it a little bit messy. So I'm going to do something a little different. We haven't seen it happen yet because we haven't had a problem like this. But I want to take that fractions denominator and I want to switch it around and put the a squared at the beginning. And I also don't like the values that are being squared to have negative coefficients at the front. It makes it messy to work with. So I'm going to move things around and I'm going to pull out a negative at the same time. Things are flying around my face, sorry. Okay, so we're going to do that. We're going to pull out a negative and we're going to move things around. So that's going to be negative 2a squared, so the negative's pulled out and the a squared's there. If I pull out the negative from the negative a, I've got positive a. And if I pull out a negative from a positive 15, it becomes negative 15. So in my answer, or my next step, I'll have a negative out in front, but then I can go back to the AC method like I was already doing. Okay, so all I did is move things around and pulled out a negative. Now we're back to thinking AC method. So a times c with the part in parentheses. That would be 2 times negative 15, which would be, good, negative 30. And b would be 1. All right, so let me rewrite the pieces that don't change. The 2a squared's the same, and the minus 15 at the end is the same. All right, so I need 2 numbers that multiply to negative 30 and add to 1. Negative 5 and positive 6. In either order, so I'll put my negative 5 since you guys said it here, there, and then positive 6a here. Right? Those multiply to 30, add to positive 1. We're halfway done with all the factoring. Yay. All right, AC. A times C for 4a squared minus 20a plus 25. 100. Wow. What's B? Negative 20. Careful, got to keep the sign too. Yep, negative 20. I need 2 numbers that multiply to 100 and add to negative 20.
Negative 10,
Negative 10 and negative 10. Good. Okay, so the parts that stay the same are the 4a squared at the beginning, the 25 at the end, and then we're going to have negative 10a, negative 10a. Okay, last piece to factor. 6a squared minus 7a minus 20. A times c. Negative 120. And b, negative 7. Okay, I need two numbers that multiply to negative 120 and add to negative 7.
Positive 8, negative 15.
Excellent. So the 6a at the beginning, 6a squared will stay the same, and 20 at the end, negative. And then what were my numbers again? Negative 15?
And positive 8.
Negative 15a and positive 8a. Okay, so we actually aren't done with the factoring, but we're done with the AC parts that we can do the factoring, right? Right. Okay, so let's do our factoring. Let's do those two pieces. It'll take us a couple steps to do that, but we're going to go piece by piece. 3a squared minus 3a, I can pull out a 3a, leaving me with a minus 1. 4a minus 4, pull out a 4, and a minus 1. Good news, the a minus 1s match. Yay. Denominator, don't forget the negative. I'll use a bracket just to differentiate. 2a squared minus 5a, I can pull out an a, leaving me with
2a.
Good. 2a minus 5. 6a minus 15. 3. Good. Leaving me with? Correct. 2a minus 5. Okay, numerator. Second numerator. 4a squared minus 10a. 2a. Leaving me with? 2a minus 5. Negative 10a plus 25. Well, first of all, I do want to pull out the negative because I need my signs to match here in a minute, and that will be necessary. Number-wise, what do they pull out? 5, right? Leaving me with 2a minus 5. Make sure you got the minus. It is minus because I changed my signs by pulling out the negative 5. Denominator, 6a squared minus 15a. 3a, leaving me with? Lots of 2a minus 5s in this problem. How about the 8a minus 20? Positive 4, good. Leaving me with 2a minus 5, also a good thing, right? Oops. Okay. Very, very good. Last step for the factoring then will be to clean up what we've got pulling out of each of the pieces. The first one has an a minus 1. So I pull out a minus 1. And I'm left with 3a plus 4. In the denominator, I pull out, well, first of all, there's a negative. Don't forget it. And then I pull out a 2a minus 5. And I'm left with what? A plus 3. Good. Second fraction, numerator. Pull out 2a minus 5. And I'm left with 2a minus 5. I told you there's lots of 2a minus 5s. Beautiful things are about to happen. Just hold on. Okay. Second denominator. There's another 2a minus 5 there. What am I left with? 3a plus 4. Right. Oh, so much cancels. You just can't hardly wait. Okay, top to bottom, look at the first fraction. Is there anything on the numerator with the denominator here that can cancel? There's not. How about the second fraction? Yes, one of the 2a minus 5s. Okay, so top to bottom is one of the places we need to look. And then we're going to look along top left, bottom right, diagonal. Anything from here that would cancel? 3a plus 4. You bet. All right, and then the bottom left, bottom left to top right, the second 2a minus 5. What's left in my numerator? A minus 1. And in the denominator? Negative, don't forget that, yeah? A plus 3. You can leave it with the negative pulled out like this. It's totally fine. If you want to distribute the negative through, that's fine too. Either way doesn't matter. Okay? Now keep in mind, the only way we cancel is factors. So I can't like cancel the A's here. That would not be appropriate, right? Those are terms, not factors. So I have to have factors in order to cancel. You guys did well. Very good. You have no idea how badly it went in my first class. It was my fault, actually. I kept making mistakes. I kept putting numbers in the wrong place. So we did a good job. You guys did fantastic. Okay, you guys kept me on track. Let's take a look then at number 8. Number 8 feels like a kind of funny question, but it's leading into something else. So let's take a look. Convert x plus 2 over x minus 8 into an equivalent expression with a denominator of 16 minus 2x. Okay, so we want to change the denominator so that the denominator says 16 minus 2x. There are options of how you could think to do that. I think the easiest option is to look very carefully at the x part of the denominator. This x is just x, and this x is negative 2x, right? So what would I have to multiply the actual original denominator by to make it actually say negative 2x? Negative 2, both pieces, right? I'd need it to be multiplied by negative 2. So I go back to the problem's original fraction, and I will multiply the denominator by negative 2. But I have to do that to the numerator, right? That's the only way that that's allowable. Why am I even allowed to do that? I don't know. Okay, honest, very good. I appreciate that. Somebody said it, though. Yeah, it's the same as multiplying by 1. And when we multiply by the number 1, things don't change, right? So that's why it's an equivalent expression, because I'm really just multiplying by the number 1. Because 2 over 2 is 1, right? Yeah. All right, so if I multiply the entire numerator by negative 2, what do I get? Negative 2x minus 4. And the denominator? Right? Fantastic. And if you wanted it to really, really look like this denominator, you could switch the addition around in the denominator so that it said 16 minus 2x. Okay? I mean, it's the same thing because it's addition, it's commutative. Okay? So either of those answers are perfectly fine. So this one or the one on the right. Okay, so why would we randomly want to change the denominator to look like something else? Well, because it's usually not random. That's why. Okay, there's usually a reason. And in particular, the reason has to do with adding and subtracting fractions. So if you'll remember about 4th, 5th grade, whenever it was you learned about fractions, multiplication, division, that was the easy stuff with fractions. Addition and subtraction, not so easy. And because the reason is because they have to have common denominators. So that's the order we're going in as well. We did the easy, multiplication, division, and now we're doing the more difficult, addition, subtraction. Now, the key to doing addition and subtraction is that we have common denominators. Right now, it doesn't even look like we have a fraction with the number 1. So the first thing we might want to actually do is to change that into sort of its fractional form, which means writing it over the number 1. Negative 1 over 1. But I want the 1 in the first denominator to match the c in the second denominator. So what do I have to do to get that to happen? I have to multiply by c. But if I multiply by c on bottom, I have to multiply by c on top. So if I do that, I have negative c over c minus 3 over c. And once the denominators do match, I can rewrite the denominator one time. And I can combine the numerators all together into a single numerator, which is negative c minus 3. There's nothing else I can do to simplify that because c and 3 are not like terms. Sometimes they will be like terms, and I can simplify. But on this one, that right there is as far as I can go. Sound good? Right. Second fractions. Number 10. What did we say have to be true about the denominators? They got to be the same, right? They got to match. They have to be equal. These denominators are not the same. And the only way that I can get them to be the same is to figure out what their factors actually are. Now these are not bad. We're not going to do the AC method because these have coefficients of 1. They have values at the end, 6 and 3. Those are not hard to factor. So factoring these with just trial and error is very straightforward. So we're going to do it that way on this one. If I factor this one, obviously I have x and x at the beginning. I need two numbers that multiply to 6 and add to 1. Good. X plus 3 and x minus 2. Everybody good with that one on the first fraction? Excellent. Second fraction. Again, two parentheses. They both start out with an x. I need two numbers that multiply to the 3. That's my last value. And they add to 4.
X plus 3, x plus 1.
Good. Plus 3 plus 1. So my comparison for getting these denominators to be the same now is a comparison of factors. They have a factor that matches x plus 3. Agreed? So that piece is there. We're good to go. But they also have factor pieces that don't match. In particular, there's the x minus 2 in the first one, which means I need an x minus 2 in the second one. And if I do it to the denominator, I got to do it to the numerator. And in a minute, when we do it to the numerator, we'll have to FOIL that out. The second fraction has an x plus 1 in the denominator. So the first fraction needs an x plus 1 in the denominator. And we'll have to, again, FOIL that out. So whatever I multiply on the bottom, I have to multiply on the top. Here's the best news of the day. You ready for the best news of the day? I mean, this tops like any other news right here. This is amazing. You don't have to multiply the denominator out. Okay, that is good news. Do you really want to? I didn't think so. Okay, so don't act like that's not good news. It's definitely good news. The denominator is simply x plus 3, x minus 2, and x plus 1 in any order you like. Those are the three factors, and they're going to be there. The numerator we do have to factor, or not factor, excuse me, but FOIL out. Now the good news is, do you remember? Oh, somebody said it. Say it loud. It's a difference of squares. The inside terms, the outside terms cancel because they're the same in different signs. So when I FOIL this out, I will actually get x squared minus 1 when I multiply the first set out. The second set I need to be a little bit careful with because there is a subtraction sign between these two fractions, so I need to make sure I'm subtracting everything after this. Okay? When I multiply this out, x minus 2 times x minus 2, that's not a difference of squares, so I do actually have to multiply it out. X squared. If I do the outside term, I get negative 2x. If I do the inside term, I get negative 2x, so that's negative 4x, and then plus 4. I am going to need to distribute that negative in order to be careful as I combine the numerator pieces together. The denominator will stay the same. The numerator has x squared minus 1 minus x squared plus 4x minus 4. So what combines in the numerator? The x squareds. In fact, they combine to nothing, right? What else combines? Negative 1 and the negative 4. So whether you write it first or you write it second, you'll either have 4x minus 5 or negative 5 plus 4x over the same denominator. Here's the real reason why we're not going to multiply the denominator out. If the denominator is in factored form right here, I can see at a glance that there's no way the numerator simplifies with it, right? If you go and multiply that denominator out, you can't do that. You have to work hard at figuring out whether or not it's really in reduced form again. So there's no reason to multiply it out. And it is certainly not simpler if you did. It would be more complicated, much messier. Okay, any questions on this one? All right, the next two are going to look a little bit funny. They're one at a time. They actually have a name. We call them complex fractions, and a complex is not meant to be the word complicated, okay, although it certainly looks complicated. But when we write fractions over a fraction like that, we call it a complex fraction. Keep in mind that it's just really another way of writing 9a over 35 divided by 6 over 25a, right? I mean, that's what that division sign between the two fractions really means. And you already know how to do that. because we did a problem where it had division. So what do I have to do for division? Flip it. Which one? The first one or the second one? The second one. So that's the 25a now over 6. And, okay, what operation am I going to use? Multiplication. I did the reciprocal. That's true too. It is a reciprocal, and I'm going to use multiplication. And then I'm going to do what you suggested, which is to look for factors in common. You can go again each fraction at a time, 9a and 35. Anything in common in the first fraction on top and bottom? Nope. How about the second one, 25a and 6? Nope. All right. Top left, bottom right diagonal, 9a and 6. 3's. So divide by 3, I get 3 and 2. This other diagonal, 35 and 25a. I have 5, so I have 7 and 5. Then I multiply across the top. 3a times 5a would be 15a squared. On the bottom, 7 times 2 is 14. Beautifully done. And you're finished. Right? And very, very obviously, 15 and 14 have nothing in common. And because we did all the simplifying at the beginning, that's why. Okay? Okay, so I'm going to flip the screen, and nobody's going to leave the room yet. You're not freaking out on me. You're just going to write it down. Okay? You guys are so much fun. Okay, there you go. It looks worse than it is. Promise. Okay, so it's still called a complex fraction because it's fractions within fractions. It's worse than the one before because the whole numerator is not a fraction, right? I have one part that is and one part that isn't. Same thing for the denominator.
And it includes subtraction.
And what?
And
It does include subtraction, so we have to be careful with the subtraction on distribution. It's really easy to lose negative signs, as I'm sure you have all done at some point. I know I have. There's at least 2 ways to do the problem. One way is that you can get the entire numerator to have the same denominator and make it all one fraction. And you can do the same thing with the denominator. Make it all one denominator, make the denominator all one fraction. And that's a perfectly legitimate way to do it. There's nothing wrong with it. The other way is to simply get rid of the fact that there are double fractions. And that's my choice. I'd like to get rid of the double fractions as quickly as I can because the problem simplifies, or at least seems to simplify easier that way. Now, the good news on this problem is that the little denominators match. They do, right? They're both y plus 2. That's really useful to us. And here's why. Instead of trying to make all these things have little denominators of y plus 2, we're just going to get rid of the y plus 2. Okay? So how do we do that? Well, we get rid of a denominator of y plus 2 by multiplying by it. And we're able to multiply the top and the bottom by the same thing because it's equal to 1. So I'm multiplying the entire big denominator, that is the entire top, by y plus 2, and the entire bottom by y plus 2. Now, in doing that, I have to remember that I got to distribute. So it means that this y plus 2 gets multiplied by the y at the beginning, and it gets multiplied by the fraction at the end. And the same thing happens on bottom. Y at the beginning, fraction at the end. So we need to multiply the y at the beginning by y plus 2. And I'm going to just write that down, y times y plus 2. But check out what happens when I multiply the y plus 2 by the fraction y plus 6 over y plus 2. The y plus 2's cancel, which is the real reason we did it, right? All it leaves me with is first the negative, and then, in parentheses, the y plus 6 from the numerator. Because when these two get multiplied, the y plus 2's cancel. And the same thing happens in the denominator. The y at the beginning is multiplied by y plus 2. There's a negative. And then again, the denominator y plus 2 cancels with the multiplication that we're doing, y plus 2, to leave me in parentheses with 4y plus 15. And already the problem feels so much better, right? It does. There's so much less going on. Let's do the multiplication. What's y times y plus 2? Y squared plus 2y minus y minus 6. Denominator, also y squared plus 2y, and then minus 4y minus 15. All right, let's clean up the numerator. What do I have? I'll start you out. Y squared. What else?
Plus y.
Plus y minus 6. Denominator.
Y squared.
Minus 2y minus 15.
Uh-huh. Yes. It's really hard to tell right now if we're done or not. Because the whole goal when we're working with fractions is to simplify if we can. And we have no way of knowing really right now if this is simplified. Because it's not in factored form. Okay? So we're going to factor it and see if it simplifies any further. Sometimes the answer will be yes, and sometimes the answer will be no. But you won't know unless you try. Again, the factoring for this one's really nice because we have coefficients of 1 in front of x, in front of y squared. So the top one is y and y. And I need two numbers that multiply to negative 6 and add to 1.
Positive 3, negative 2.
Positive 3, negative 2. In the denominator,
Negative 5 and positive 3.
negative 5, positive 3. They multiply to negative 15 and add to negative 2. And what do you see? They do simplify on this one by canceling the y plus 3's. So my final answer, in completely fully factored form, is y minus 2 over y minus 5. Any questions on that one? Yes, ma'am.
Why couldn't you go ahead and just cross out the y and then
Which one?
the third step?
Y
The second step.
In here?
Yeah.
Okay. So the problem right here is that each of these pieces are not factors of the whole thing. They're only a factor of this portion, right? This doesn't have a y plus 2 in it, and this doesn't have a y plus 2 in it. So if you start canceling before you've got it completely factored, you're going to end up canceling something that doesn't work. It's kind of like this. If I had 15 plus 3 over 15 plus 4, I can't do that, right? And it would be the exact same thing as trying to do that.